So our second speaker is Dr. Reza Farzaneh, manager of TTI's air quality program. He has over 16 years of transportation research experience, mainly focused on transportation air quality, traffic flow, and vehicle activity analysis, and applications of integrated data systems and visual data analytics.
Thank you very much. Thanks for the intro, and thank you everyone for being here. So, kind of as an opening, it may be a little bit. I realize that it must be a different audience that I'm used to, so I need to kind of provide a little bit of background. TTI is the largest university-based transportation research institute in the U.S., and we do research on everything that has transportation in it. And our small corner deals with air quality. And so our business is research, and that's the context about this this presentation. Basically, we are. I mean, probably you've seen this and heard if you're dealing with data. Data is not valuable by itself. I mean, you can have tons of data, but unless you can translate it into digestible information, which, by the way, takes a lot of work. It's not visualization yet, but I'm laying out the context here, and that's what we do in research, really. And what has become critical in the past few years is really, the amount of data. I'll call it emerging data sets. What's different is that data volume. We have more and more of it. We have the frequencies has become almost real time in many cases, and we have a variety of that's coming together. This has created a challenge it's a great opportunity, but it's a challenge to really take all this data and translate it into information. And that's what basically where we come into play as researchers, and the industry is dealing with that. Google is doing a great job in that. So our little piece really, about 4 years ago, we started kind of looking around and realized that we need to change our way of doing with data. We've been using data since I started working at TTI, and people were using data but what has changed is the amount of data now we have, and now the tools that we have modern tools became available, and now it was an opportunity that we gladly kind of embarked on. So we identified Microsoft Power BI as a system that can help us to basically address that challenge. Most of the people how many of you are familiar with Power BI? Great, that's a great percentage, 2 out of maybe 10, 20%, good. How many of you know Tableau? It's a great percentage. That's persistent everywhere. Tableau has more name recognition in terms of the capabilities, and I'm not talking about just the visualization capabilities. All the things that is on the backside of it that Microsoft has heavily invested in, that's the part that makes it so powerful, really. And that was we are using it as an integrated data system. I'm not going to go deep into on that because this is about visualization. What it enables us to do is basically automate all the steps from accessing the data all the way to analyzing and visualizing. And I'll give you examples of that through 7 examples that we've done. Those, I've kind of broke it down into 4 bigger steps. The loading, cleaning, shaping, that takes a lot of time. That's the query part of the Power BI. Then the data integration, bringing data fusion, putting all those tables. And by the way, these are all from our project. So you see one of those, all those tables, bringing it together, traffic, speed, all sorts of things. Then doing calculations of it. In our case, it's emission estimation. And then visualizing and doing more analysis, more in-depth analysis of it. So on the last leg of it is really being visual, interactive, really, really important interactive part. And then it can do on-demand calculations, and statistical analysis is part of that as well. So examples that I want to kind of to walk through that work that we've done. This specific project was one of the first one that we did about 3 years ago. Hoteling idling is basically when truckers have hours of service requirements. So after 10 hours of driving, they need to stop and have rest for 8 hours. So when they stop, they tend to stay in their cabin and keep the engine running so they can use AC and other things. And that is a source of emissions that needs to be accounted. And that's why that we addressed. So we kind of looked around, see just traditionally people go out, do limited surveys in truck stops and then come back and analyze it. We want to do something different because there is a potential here. We have more data. So we approached INRIX. We got an A3, if you're familiar with that, those are the data providers. So we got samples of data from the individual trucks, their movement, sampling rate of 1 to 15 minutes for those, for 3 counties that are metro areas, Houston, Dallas, Fort Worth, and I believe this was El Paso as well. So we looked at those and said, we have this data from different seasons. We can now play with it. And this is the process that we went through. We loaded in the data into Power BI and started. Basically, starting with more than 200 million records for all those individual trucks, all the movements over there, not just idling, aggregating it and cleaning it up, bring it down to just the places that these people stop and idle. And then kind of even more than that, just the individual places and all the combinations, all their activity while they're over there, translated it into trends. So over there, some of those, these are just a couple of the graphs that we created from those. Basically trends, seasonal trends. So what happens between different, that was one of our questions. And then comparison between the areas that we had over there. And all of this is interactive. So basically we can say, okay, this is the regional trend, but I really want to know what's going on in that specific location. So I click on that, everything else is immediately updated, and I have the trends for that specific location. So that from a researcher perspective, if you've done data analysis, it's huge improvement. If you want to replicate things, you need to go back, okay, I want to do this, let me filter it, and then go through the process. But you can do it just by one click here. So once that's the automation part. The other piece, the second example, basic traffic data. It's backbone of many things transportation, including air quality. So we are the user of text or traffic data. These are basic traffic data, annual, average daily traffic. So TxDOT is in charge of collecting and compiling all the traffic data. Usually it comes in different, used to be static maps. So as users, we took this, so we can do this. By the way, this is Tableau because the amount of data was not huge, so we kind of incorporated in Tableau for this one. And then we said that we can do better. We want to be able to see to look at the trends, not just one number, and be kind of quickly interact with it. So I'll give you the dashboard we developed for this one. It basically shows you can go to a district, look at different locations of the data, look at the trends, and if there's something suspicious, you can click on it and see what's going on. For example, this has very low ADT. We have the actual map from Google. So you can go there, you see that it's a road closed. And that's why there's not much traffic recorded over there. So this is, it's done in a span of 30 seconds. This used to take maybe an hour or two. Example number 3. We did a study in Houston looking at Drayage trucks. Basically, these are short haul trucks taking loads locally within Houston. We collected data second by second, engine and location and speed data. And the idea was to look at their emissions impact, specifically idling, where it's happening, for how long, what are the trends. And of specific interest was the idling and activity within the different terminals of Port of Houston. And so we collected all the data, and you can imagine many millions rows of data, analyzed all of that, extracted the trips and idling and calculated emissions and all of that. But that's not really, I mean, we can generate static tables and just publish a report, but we wanted something to be able to communicate with our stakeholders, and that's why we kind of put it in the visual format. This shows that dashboard over there. You can interact with it, and you see immediately the trends jumping out for each of those terminals. You see that some of them, you have throughout the trips throughout the day, activity throughout the day. The other ones, no, just focused on that, and then you can focus on specific hours. So again, from a research standpoint, huge improvement in terms of the efficiency, in terms of the amount of knowledge really can be extracted from the data. How am I standing on time?
15 minutes.
Okay, I can go slower then. So this is another one from the same study. This one looked at the trips. So basically, we identified trips based on every time a truck stopped more than 5 minutes. So that was a kind of a start of a trip, and then until they stopped again, we kind of tracked them, origin and destination. So I don't know if this, yep. So we can kind of look at the destinations or origins of those kind of throughout the area, and then interact with the data. So this is the trend in terms of the distribution of the time that a trip started and the distribution of the time that the trip ended. So if we want to see that what's happening, all the trips that are starting at 12, we click on it, we immediately see the distribution in terms of, trip endings right here. And by the way, map is also filtered, so only shows the trips that are kind of started at 12 o'clock, and you see the log normal distribution over there. Application number 4. I mentioned statistical analysis as part of it. When it comes to hardcore data, all the visualization, all of that is good, but if you talk to data people, they want hardcore numbers and a statistical analysis. Some of that can be done. I'm not saying that all of it can be done, but some of them can be done within Power BI, because Power BI has Python and R integration. So you can write some codes, statistical analysis in Python or R, and bring it in. And then the beauty of it is once you establish that, you link it to your data, and you can interact with it. So you don't need to run that code ever again yourself. You park it over there, you do this analysis, let's say for Wednesday, you want to have it run it for Tuesday. You just click on Tuesday, everything is updated here. So you see that the huge improvement again in terms of the efficiency, looking at the data, and we've used this capability extensively. Basically, is a huge improvement in terms of the speed of the operation. Same study, by the way. This specific study was looking at the impact of traffic on near road air quality. That's a new topic of interest these days. And we've done some modeling as part of that. It's a corridor in Dallas. And in terms of kind of showing the results, we brought all the data, again, millions of rows over there, to show that how the concentration is as you move away from the road. It's highest, it's about many times higher when you're near the road. As you go away from the road, it all fades away. Then this was PM 2.5. Same study looking at different, we modeled many scenarios. So you see that we wanted to kind of be able to look at different scenarios, and upwind, downwind. We looked at 2 areas, all those combinations of parameters. The other one, this one was looking at emissions impacts of border drayage trucks. For those of you who are not familiar with the border operation and freight operation at border, at the U.S.-Mexico border, basically there is no through traffic when it comes to freight. The load goes to the commercial zone. They drop it over there at either side of the border. A drayage truck, which is usually an older truck, takes it from one side, bring it to the other side, drops it, and then another long haul truck. So it's very inefficient, but that's something put in place many years ago, and as a result of, I mean, it's enshrined in NAFTA and the new one as well. So it's not going away. It's a very inefficient, but it's a reality. And that's a source of emissions. These are old trucks operating and day in, day out. And so we've done some data collection over there, second by second again, a sample of that, and looked at all sorts of parameters, emissions. What I have here, basically, that is PM10 by, I believe it is, time of day. We also looked at day of week and other trends as well. And we have the speed and the distance. So we can break down the data easily, also kind of showing all the results on a map. This is it's getting towards more of the statistical analysis type of applications. We are doing right now, we've collected some data on emissions from oversized overweight trucks, second by second, and we are analyzing the data. 3 trucks, 4 different loads, and I think it's 7 or 8 pollutants. So it's a lot of data again, and we need to develop emission rates for each of those, and looking at all the distributions, all the variability in it, and see that whether it's different from what is in EPA's model. So this is kind of our command center, that we bring all the data over there. We can interact with it easily, by the scenarios and the vehicles. This is the vehicle. This is the scenarios that we have, and the pollutants. And this has, again, it's hugely improved our operation in terms of identifying what's going on. Should we look at this more closely? And then we can kind of see the scatter plot and identify the areas that we need to examine in more depth. This shows one of the things that we did in the same study, basically on the time alignment of the different data that comes from the exhaust measurement. We're looking at that. They need to be time aligned very precisely. So it's kind of, that was the old way of doing it was in Excel and tedious, going back and forth, but this is really, we can look at all those pollutants, all those combinations very easily. Last but not least, this has been basically, we are using a lot of traffic simulation, dynamic traffic, DTA, dynamic traffic assignment, and also micro simulation. So outcome of those is basically link-based traffic flow and speed or movement of individual vehicles. And then those are used basically, these are the tools that traffic engineers are using to determine what's the impact, usually in terms of delay and travel time of a certain project or a strategy. This specific one, I believe it's a highway emergency response program in Austin. So TxDOT has a program over there. They wanted to see that along the I-35 corridor, what is the impact on delay and what is the impact of emissions and other things. And we basically modeled that and took out all the things and then put it in this. We built this in all of it in Power BI. And this has been the most intense application of Power BI that we've done. Basically, all the steps, we've had about 20 gigabytes of outputs from the data, from the model. So just connect to those files, set it up, clean it up, put it together, do the emissions estimations, visualize it, and then also do all the analysis, statistical analysis. Once it's done, we have Neuron. We can just plug it and basically set our system, go, that's the file over there, that's the folder, go over there, and it does it automatically. It goes, reads, and every translate in 10 minutes we have the result. Those of you who you have done it, that's few days of work, really. This is kind of shows that how it's one of the dashboards, that how it works. This was another study. This was looking at ramp metering, impact of ramp metering on emissions in Dallas-Fort Worth area. So basically, these are all we can filter it. One of the things is that we can filter all of these by the type of road. We looked at different basically corridors over there. You see 2 corridors over there, and different buffer sizes. And buffer sizes, that's the concept we are using basically to account for the impact of that corridor. Whatever we do on the highway, it impacts within a distance. So we are accounting for those changes as well. So we can select all of that, and all those numbers are updated immediately. So we can look at many scenarios now. That's another one from the same study. This one looking at delay. We have the travel time and delay visualizations as well. So very easy and effective in communicating all the results with our stakeholders. Thanks for the opportunity.
Any questions?
Yeah, the one slide that stuck in mind
Which one?
was the one showing here's the level of the PM 2.5, I believe it was, as you get away from this corridor. Kind of harks back to, hey, we're swimming in our own cesspool of air pollution, things like that. Have you worked with any of the EV adoption initiatives saying here, you know, help people understand, you know, not only the GHG aspects, but also the emissions aspects to either nudge policy or nudge public to buy more or anything like that? Have any of these visualizations been effective in that area?
We have not on, specifically not on EVs. I mean, we just started this week a project that's specifically focusing on impact of EVs on regional emissions. So maybe in 2 years, another year, I can come down and give a talk about that.
A follow on that, we'd like to talk to you. My
I
colleague
would love.
right behind me, Jeff, is we're working with the University of Maryland to try to get better exposure to GHG emissions and energy, and you know, getting from the facts to something that's appealing to a planner or to the public. And that's the one slide saying, okay, let's put some visualization of here's this corridor and the traffic and the emissions shed on it, and that would be very effective.
I would love to.
Yes, this is probably clear to a lot of other people in the room, but are these kind of fixed points where the air quality is being fed to you all the time, or do you go out into the field? And it sounded like, at least for the border project, maybe you went there and you actually camped out there for a while and measured, or is it ongoing? Is the data always streaming in, or is it?
We have a combination of things. Right now we don't have any live streams of data that is being kind of visualized. They don't have it. I mean, that's basically our business model is. There's a question, answer it. You know, that we are not Google. So we haven't had really an opportunity to it. But we've dealt with that, some of our data collection. So we deal with all the data that relates to vehicle activity and emissions. We've used the data stream basically from the monitors, the ambient monitors, vehicles. I mentioned INRIX, basically vehicle probes and all sorts of it. So anything that has air quality or vehicle activity in it, I mean, I also mentioned models. Models are a big part of it as well.
And is there any room for like citizen science measuring? Is there any equipment out there that's suitable for that?
Yes, there is a room, and I don't know how familiar you are. There's a push right now, started not surprisingly in California. It's a community level monitoring, and these are basically lower cost monitors that people can buy and put it, and there is a lot of interest in kind of bringing that data together, and TCEQ, which is equivalent to EPA in Texas, has shown an interest kind of moving in that direction and looking at that. So yes, this is the future, really.
And just an interesting observation that what's cool about the visualization tools and these very complex things that we can see that help us kind of figure out what the challenges are. But what's fascinating is many of the answers are the simple bar chart. You know, when it comes down to trying to make a decision maker understand what happens, it comes down to the bar chart. Just a fascinating.
Yeah, and don't use pie charts, by the way.
Very good, thank you.
All right.
Appreciate that.